Hello. Today in this video, I'd like to talk to you about circuits and circuit diagrams. We're going to explore the different components that can be in a circuit using circuit symbols to represent those components. We're going to talk about the difference between an ammeter and a voltmeter. And then finally, we're going to look at some example circuits to see how these things play together. Now, before we go too far, let's develop a rigid definition of what an electrical circuit is so we can see how these components play a role. An electrical circuit is a pathway through which current can flow. And as you can imagine, this pathway can really consist of anything. I want you to really think of this question here. What are electrical circuits typically made of? When you picture an electrical circuit, maybe you picture something like this that has, wires, maybe it's glowing blue, it has metal in it, it's made of conductors. But think outside the box. What are things that you have that have circuits in them, or use circuits, or are inside of an electrical circuit? Maybe you're to think about a light that's in your home, or a toaster that's going to be hooked up to an electrical circuit. It's going to have a circuit inside of it that has a resistor inside that circuit as well. Motors are often used in circuits. Any of your toys or devices you have at home that have anything spinning or things like that will use a motor. And there's so many more things we put into circuits. So one of the most important things for us to have then is a language we can use to describe the different components that are in circuits and how they're all hooked up together. And that was the motivation behind developing circuit diagrams. So a circuit diagram, also called a schematic, sometimes you'll see those on movies and things, it represents the typical objects found in a circuit. And if you look in your reference tables, there's an entire list of different symbols that we're going to use to describe different circuits. So you've got cells, you've got a battery, which is made up of multiple cells, switches, voltmeters, ammeters, resistors, variable resistors, and lamps. And of course many more, but we're not going to talk about much more than these ones here. Now, to look at some example circuits, I want to talk about the difference between a voltmeter and an ammeter and see how they play different roles in a circuit. So the first one's a voltmeter. A voltmeter measures the electrical potential in a portion of a circuit and must be hooked up in what we're going to call parallel. So what we mean by parallel is let's set up a simple circuit. We're going to take a battery here, or just a cell. We're going to hook it up with a switch, and then maybe a resistor here, and then back to my battery. Now, if I wanted to measure the electrical potential between points, let's say points A here and points B, to measure the potential between those, remember what electrical potential means. It's that energy that an electron would gain or lose flowing from A to B or B to A in a circuit. And so to measure that, we don't want to break this circuit up. We wouldn't put the voltmeter in the middle of the circuit because that would change the pathway, and thus that would change the energy that you get in that circuit. So we hook it up outside of the circuit. And when we say outside the circuit, what we mean then is parallel. So parallel is hooking it up to where my voltmeter is now on those sides, and then we're going to put our voltmeter in the middle. And now we can measure the electrical potential between points A and B. So why? It must not interfere with the path of the circuit. And so we hook our voltmeter up in parallel. Voltmeters, just so you know, have a really, really high resistance, which makes this work, because that means if this has a high resistance, more electrons, in fact, most of them, will flow in the original way and not through the voltmeter. And so in that way, it doesn't really alter the circuit much. Now, we've got our diagram here. Let's talk about ammeters. An ammeter works a little differently. It actually measures the current flowing through a particular point. And so we need a way to count or see the electrons passing through that point. And so it shouldn't be hooked up in parallel. Instead, we need to hook up an ammeter in series. We're going to call it series. And why? Because that ammeter must, I'll use quotation marks, see or measure each electron that passes through. And so series circuits look a lot more like what you probably typically think of a circuit, right? Where if you have like your battery here, we'll hook up multiple cells this time, and then now I've got my resistor, and now I'm going to go back to my battery. instead of measuring the current between 2 points, instead, ammeters measure the current like at a point. Like if I wanted to measure the current at A, well, I would need to put my ammeter in the path somewhere where it feels all the same electrons as A. And so we could go ahead, put my ammeter in here at A, break my circuit up, and I'm good to go. Notice how when you put an ammeter in, you're always breaking up the circuit. And so we'll say that's our diagram for our ammeter here. Okay, let's take a look at some example circuits. So our first example says, draw a circuit with two 50-ohm light bulbs and a 120-volt power source. Well, when drawing circuits, one thing to note is now we have numerical values in here for our resistance and our voltage. Well, you'll always want to make sure you include these numerical values in your circuit diagram in order to differentiate between different components of the circuit. So for example, I'm going to draw my 120-volt power source. So I'm going to label that as 120 volts. And then I'm going to wire my light bulbs up. Now you could do, it doesn't say, you could do this either in series or parallel. Let's do it in series first just so we can see how series circuits work because they're typically a little simpler. And there's my two light bulbs. Finish the light bulb with a glass casing. We're going to say these are both 50 ohms. And now I've got my simple circuit here. Now notice they don't have to be right in a line there. You could go loop around. As long as it's one path, that's a series circuit with my two light bulbs. Contrast that with this one here. Now we want to draw three light bulbs in, 120 volt power source and a switch, and add ammeters and voltmeters to do our measurements here. Now we're going to keep this simple here, so we're going to do series again, but we'll do some parallel examples in a second. We have our 120 volt power source. Now we want to do three 80 ohm light bulbs. So I'm going to line them all up down here at the bottom. There's my light bulbs. Come on back, switch in there. And then I've got light bulb 1, light bulb 2, and light bulb 3. Now series is nice and easy to measure current in because if it's all in one line, I just have to break the line at one point, put my ammeter in, and I'm good to go. That ammeter will measure the current in that circuit. To measure the, I'm going to go ahead and label my bulbs at this point now, they're all 80 ohms. Now to measure the voltage across each light bulb, I need to isolate the 2 points on either side of the light bulb. So I would connect my voltmeters in parallel around each light bulb. And you could do this with just one voltmeter, just moving it each time you wanted to measure the potential. And in fact, we're going to do an activity like that where we measure voltage across different light bulbs or resistors or something in a circuit here. So here we've got a voltmeter around each light bulb. Now let's contrast that with doing something kind of in parallel instead. So now instead we've got three 80 ohm light bulbs, 120 volt power source and a switch, add an ammeter to measure current in the circuit, add a voltmeter to measure potential difference. Let's go ahead and try this one in parallel instead. Now parallel gets its name because it looks like the circuit is all parallel. So I'm going to add my switch in here. Then we can go ahead and add my light bulbs, now all parallel to each other. And then we're going to bring them back around and back to my power source. Now, I want to measure the current in the circuit. You could measure it different places, and they might all get you different values. You might measure here at A, you might measure here at B, you might measure here at C. Now, those will all be the same only because we have the same 80 ohm light bulb down each path. But if one of these particular paths had more resistance, maybe less would go down there. So a more optimal place to measure the current might be someplace like D, because all of the electrons still have to pass through that one particular point because it is the only path to get back to my battery for my electrons here. Now if I want to measure the voltage, in this case each light bulb should have the same voltage down it, and we'll talk about why. So let's go ahead and add our voltmeter in here kind of across the outside of the circuit. And now I've got a circuit with a voltmeter and an ammeter. Finally, draw a circuit with a 10 ohm resistor, a 50 ohm resistor, a 70 ohm light bulb, a 240 volt power source, add an ammeter and a voltmeter. You should be able to do this on your own now. So go ahead, give it a try, draw on this circuit here. Either do series or parallel, and we'll come back and take a look. Okay, so to draw this out, we've now got a 240 volt power source. Put in our 10 ohm resistor. I'm going to go ahead and do series here because I find series easier. So I've got 10, 50 ohms, 70 ohms, and then no switch actually. Oh, but this should be a light bulb. So don't forget to make sure you differentiate between the different types of things you could have in your circuit here. An ammeter goes in series with everything else, and so we'll put it in series there. And then our voltmeter across each light bulb, well, there's only one light bulb, so we'll put it in the middle here. And boom, we've got our ammeters and voltmeters all wired up. Okay, so that's how to go ahead and draw circuit diagrams and include circuit components. Thank you very much, and I'll see you guys later.